so as we can see in the table, every time, oh, that's not a pen. Okay. Every time we go down, it goes, we just divide it by 2. So 64 divided by 2 is 32, 32 divided by 2 is 16. So you just keep doing that. So this would be 8, this would be 4, this would be 2, this would be 1, this would be 1/2. That would be 1/4, 1/8, and 1/16. So that's the relationship.
Are there questions so far for Bryn? No. Okay. Did anyone think of this? I'll take the microphone. Okay. Did anyone think of this a different way other than dividing by 2? Did anyone think of this a different way other than dividing by 2? Bryn, would you please pick a boy with his hand up? So we're waiting for Alex to come up to the board. Do 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 do. Do 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 do.
And you put it right here. I don't know. So also, no, okay, cord move. Thank you. Also, what you could do. So since Bryn already filled in the table, and if you, so you could do it divide by 2, or you could do it multiply by 2. I think. Pretty sure. Wait, no, 1/2. Sorry. So, you just keep multiplying by 1/2. I'm pretty sure.
So dividing by 2, multiplying by 1/2. Is that equivalent?
Yes. See.
Yes, it is. Okay. Thank you very much, Alex.
See.
All right. So how does that affect our equation? So I know we have 2 different equations in the room. I would like very much for Grace to show us her equation. All right. Would you write your equation on this half of the board over here?
Okay, so the equation that I found was y equals 64 times 2 to the negative n power.
How many people had that as an equation? I know this whole table in the back had it. So George started with it. Alina. Okay. So let's double check. Let's see if that equation works. Because I noticed that many of your hands shot up in the air. And you waved them like... I can always count on Rashid to finish my sentences. Or did I mean sandwiches? Okay. You know. Okay, good. I'm glad you got it. Okay. So let's try this one right here. Would you like to sing for us? Okay. All right. So let's plug in 4 for n and see if it works, because the majority of you did not have this equation. Let's see if this works. So we're going to go y is equal to 64 times 2 to the negative what power? 4, because we're using 4. All right, so 2 to the negative 4. So let's have a little sidebar here. 2 to the negative 4. Does anyone remember the rule that we use with negative exponents? Trying to connect this back a little bit. Mikey?
It's going to be a fraction?
It's going to be a fraction, right? And so if we have a to the negative x power, this is going to equal, I'm just writing it in the normal rule format. Tanner?
1 over a to the x.
Okay. So this is equal to 1 over 2 to the what power?
4.
So 2 to the positive 4th is? Okay. So we have 64 times 1/16, which is equal to? 4. Did it work?
Yes.
Now, it's possible that an equation will work for one value of the table. That is very possible. But if it works for 2 or even 3, then we know it works for all of them. So I want you and your partner to pick one other point on this table.
You should probably say other than 0.
Rashid wants you not to use 0. And see if it works. So I'm going to pause the video. You in period 7, I want you to go ahead, pick one of these n values, plug it in, and see if you get the correct x. Plug in one of these x values, see if you get one of these y values. So go ahead, do that now. Go.
Okay, let's just do 1 because 1's really easy.
Okay, so at this point we should have a class full of values to see if this equation works. All right, raise your hand if you plugged in 1. Okay, did it work when you plugged in 1?
Yes.
Did anyone? Okay, that's like half the class. Did anyone plug in 2? Okay, did it work when you plugged in 2?
Yes.
Did anyone plug in 3? Did it work when you plugged in 3?
Yes.
I know a group plugged in 6. Did it work when you plugged in 6?
Yes.
Oh, so this equation works, doesn't it?
Yeah.
So it totally works. But, and so it's an acceptable answer. However, we learned earlier that negative exponents are bad math grammar. And we are, if anything, polite and use proper grammar. So did someone get an answer that, or an equation that also works, however, is written without a negative exponent? All right. Grace, I see your hand up, so you have both answers, which is great. But could you please pick a boy to come up and show? Luke. I am your father.
Okay, so the equation I did was y is equal to 64 over 2 to the a, which is number of cuts, so just x to the x.
So this will also work. This will also work. But does someone have another way of doing it? Another way of doing it. This is really cool. We're getting 3 possible equations. Luke, I think we are even on the boy-girl front. So you may pick anyone with their hand up.
Yay. I magically grew a lot.
Here you go.
Okay, so we could write it in the proper exponential format and standard form, which is y. Oh my God. Y is equal to 64 times 1/2 to the power of x.
All 3 of these work. Thank you. So what is the decay factor in this case? What is the decay factor in this case? Caroline? It is not 2. Remember, the decay factor is what you multiply by every time. Would you like to revise your answer? Yes. It is 1/2. The decay factor in this case is 1/2. So what did you notice? So let's take a really quick look at what are the similarities and differences between exponential growth and exponential decay? Oh, I don't know, Molly, what did you notice were the differences and similarities in exponential growth versus exponential decay?
The differences are that in exponential growth, the pattern is of course growing, and decay is decreasing. But the similarities are that they follow the same formula, and that if you multiply a value by a constant in both to get the next value.
All right. Sounds pretty succinct. Yes, Zach?
Oh, I just have something for E2.
Okay, E2. How does it, so what similarity and differences do you notice with linear relationships?
So for this one, it's similar because but they both have a y-intercept,
They both have a y-intercept.
And so, but then the difference is that in a linear relationship, it adds a certain thing to, for good to go to the next value, but in exponential, it multiplies by a certain value.
Okay, that's excellent. Now my last question is this. I have drawn one inverse variation and one exponential decay graph. How can you tell the difference between a graph that is showing an inverse variation and a graph that is showing exponential decay? Because my goodness, they look really similar. Campbell?
So inverse doesn't have a y-intercept, but the exponential decay has a y-intercept.
Okay, so using your rule of looking for y-intercepts, which color graph is exponential decay? The red one. Okay. Have a wonderful day. Extra help is at lunch.
What time does the bus leave?
The bus is leaving at 1.